So we're looking at chapter 1, section 1 and 2 today. The first thing we looked at was identifying the individuals and the variables and classifying the variables. So here's an example. Will you show me the money? The website boxofficemojo.com lists the widest opening domestic PG-13 movies of all time, measured by the number of theaters. The table displays some data for the top 5 widest openings of all time, as reported during a recent year. Identify the individuals and the variables in this data set. Okay? So off to the side, what do you think the individuals are? Go ahead, take a second and write down what you think. Remember, the individuals are the rows. Each row represents what? So each row represents a movie. Specifically, it says the widest opening, right? Movies. So PG-13 movies that had a lot of people come to them. So it's okay for me, if you write movies, you're good, right? What are we gathering about those movies? What are those variables? Those are the columns, right? So write down, what are all, there's 1, 2, 3, 4, 5. What are your 5 variables? Write them down. Once you've written them down, can you classify them as categorical or quantitative? Remembering categorical gives it a label somehow, right? And quantitative is a number where it would make sense to find an average. You could just write C and Q next to them, next to the variables after you listed them or above them or whatever. All right, so what did we get for our variables? What were our 5 variables? You can yell them out. Title. Theaters. Distributor. And gross opening weekend. So of these, which ones are categorical? Title. Genre. And distributor. Now, title could possibly be called an identifier because it's not really a category, it's just the name of the movie. So we might want to say identifier. Thinking of the homework online, which we don't have set up yet. I think that's probably what it would answer because it doesn't really fit each name into a category, but it's like saying like what the movie is. So the title is considered the identifier. And then so theaters and gross are considered quantitative because there's numbers. You could find the average number of theaters. You could find the average gross by the movie. Questions? So who wants to party? The students in one of Mr. Tyson's statistics classes were recently asked if you would prefer a pasta party, a pizza party, or a donut party. Here are their responses, which surprised the teacher. Can you say on the next thing? Oh, here is a frequency table of the preferred party for the 30 students in Mr. Tyson's statistics class. From lesson 1.1, make a bar chart to display the data and describe what you see. So he had 18 people choose a pasta party. I think that's kind of surprising. Or maybe you're just tired of pizza and donuts.
Tired of pizza and donuts.
You feel like it makes sense? Yeah, the tiny slices.
What if you only get like 10 noodles?
So remember that when we're making a bar chart, it always has to start at 0, the frequency line. Our bars, we want to make them like equally spaced. And then I want to show you a picture of a graph that's in the book. Kind of explains that idea of being aware or beware of pictographs. Where if like you used a picture of a donut instead of a bar. Pretty sure there's one of those in the book. They made one to show you how it doesn't really look very good. I gotta find it. Unless I put it in there. I did. Never mind. I planned ahead. So as you can see after that, here is this, maybe they got out of order. Here's a pictograph, the donut, the pasta, and the pizza. Like, it just doesn't work, right? The size of the pizza and the donut just make it seem bigger than it actually is, and then you've got this tiny little noodle for your pasta. So we can see how using a picture instead of a bar, as it looks cooler, it kind of distorts the information that you're trying to share. So it's better to just use the bars. Okay. Now, in the second graph, what's wrong with this second graph? Yeah, the second graph doesn't start at 0, so it makes that difference between the donut and the pasta look even bigger because the pasta or the pizza and the donut bars are so small. It's missing the bottom chunk of it, right? So it distorts the relationship between those values when we don't start at 0. Okay. Okay, so here's another graph. Can you show me the beef or chicken or other? Fast food restaurants generally have a variety of sandwiches, but how much variety do they really have? Do these restaurants offer diverse menu items? The side-by-side bar chart shows the percent of sandwiches at 3 popular fast food restaurants that can be classified as beef, chicken, or other. Compare the distribution of the type of sandwich for these restaurants. Okay, so when we compare distributions, we talk about how the bars are different from each category, right? Each restaurant, how the bars are different, and then how the bars are different within each restaurant. Okay, so what would you say? Take a second and write down, what would you say about what you're seeing at on this graph? Okay, so what are we noticing as a trend between the 3 restaurant chains? What do you notice? They all have more, well actually Wendy's has more chicken than beef, but Burger King has the highest percentage of beef sandwiches, the McDonald's has the second highest, and Wendy's has the least percent of beef. For chicken, Wendy's has the highest, which is actually higher than their beef. McDonald's is the middle, and Burger King is the last. And it looks like for the other, they're about the same for Burger King and Wendy's, but it looks like McDonald's has the most, right? And again, Wendy's is the only one that has more chicken than beef. Any of those statements are okay. Okay? This is not the math that you're used to, where there's one right answer. Sometimes there will be. When we're calculating probabilities and we're calculating an average and we're calculating certain things, yes, there'll be one right answer. But if you're writing words, there is not just one right answer, because everybody sees things differently and thinks of things differently. So did you talk enough about the differences that you're seeing, and was it close enough? Okay. You will notice more like when you're working on the computer homework, there's more absolutes, but it's more like dragging and dropping, and they already have it written for you, right? If you're writing it by hand, there's a lot of freedom in what I give credit for. Do you have the right idea? That's the question, mostly in statistics. Do you understand what you're seeing? Do the words you wrote show me that you understand what we were talking about? Okay, so it's okay if your answer is different from someone next to you, which I know you're not used to in a math class. Okay.